Alright, this is the third lesson in Unit 7, but it's really the fourth method of solving systems. Remember, graphing is the first method that you learned, but in this unit, you learned the algebra ways to solve. You learned substitution. In the last lesson, you learned elimination using addition and subtraction. And in this method, you're going to learn another form of elimination. This is elimination using multiplication first. And you might notice, like if we look at example 1, if I said try to do this using elimination, you should say, but I can't because the coefficients are not the same. Here we have a 2x and a 3x. I can't just add or subtract those to get rid of them. And with the y's, we have a 1y and a 2y. And I cannot just add or subtract those to get rid of those. So what we have to do first is we have to multiply either one or both of the equations so that we can eliminate one of the variables. So write this down. With elimination using multiplication, we multiply one or both of the equations so that the coefficients for one of the variables are the same number. So that the coefficients are the same. And with the star there, I put, if you can get them to be opposite signs, do that too, so that you can just add the equations together and not have to worry about subtracting. Because remember, if the coefficients are opposites, we can add the equations together, and that's usually a little easier than subtracting. Okay, so back to example 1. How can we get the coefficients of either the x's or the y's to be the same? Well, with the x's, I would have to multiply both of these in order to get them to be the same. I can't just multiply, like I can't multiply 2x times anything to get it to be 3x. So we'll get to some of those in a minute. But look at the y's. You have a 1y here, and you have a 2y there. I can get the first equation to be a 2y if I just multiply it all by 2. Better yet, I can get it to be negative 2y by multiplying it by negative 2. So, we're going to take this whole first equation. You have to multiply the entire equation, and we're going to multiply it all by negative 2 so that in front of the y, there will be a negative 2. All of these numbers are going to change because we're going to have to distribute it. But in front of the y is going to be a negative 2, which will cancel with the positive 2. They'll eliminate. So what I do is off to the side then, I write my new equation. So as I distribute, that's going to give me a negative 4x. And then like we said, that's going to be a negative 2y. And now it's going to equal, instead of equaling 23, it's negative 2 times 23, which I think is negative 46. And then I just rewrite the second equation, 3x plus 2y equals 37. And then I actually go back to the lesson that we just learned, lesson 7-2, because now the coefficients are the same on the y's, and so now I can add the equations together and the y's will go away. But the x's don't, and that's a good thing because we're going to figure out what x equals. This is negative 4x plus 3x. That's negative 1x. Again, the y's go away. Negative 2y plus 2y is 0. And negative 46 plus 37 is negative 9. Use your calculator if you need to, but I think it's negative 9. Divide by negative 1 to get x by itself, so x is actually going to equal positive 9. Alright, so we're like over halfway done with the problem. We still have to figure out what y equals, and just like before, we just take whatever we got for x and we put it back into any of the first equations. I'm going to use the bottom one right here. If x equals 9, I'm going to put it right in there. We're going to figure out what y equals. So that's 3x. Oh wait, no, 3 times 9, because x is 9. And then plus 2y equals 37. Well, 3 times 9 is 27, plus 2y equals 37. So minus the 27. So 2y equals 10, and divide by 2. Y equals 5. So here we have the solution 9, 5, because the x was 9 and the y was 5. And again, that is where those lines would intersect. If I said, all right, pull out a piece of graph paper, we're going to graph these, you'd have to get them into slope-intercept form, and then you'd have to, graph them, and they would intersect at the point 9, 5. And that's the only point that they would cross. Okay, good. So again, we had to multiply one of the equations. Sometimes we'll have to multiply both of the equations. But we multiplied one of the equations so that the coefficients were the same on one of the variables, so that then we could just add or subtract the equations together. So if we look at example 2, the coefficients are not the same to begin with. We have a 3x and a 5x. Those are not the same. And on the y's, we have a 4y and a 2y. Those are not the same either. But I can get them to be the same. I cannot multiply like 3 times anything to get it to be 5. Okay, now I could multiply both of those by something. Like I could say I'm going to make them both 15 and multiply the top equation by 5 and the bottom equation by 3, and that would go. But there's a little bit of a shorter way if we look at the y's. Look at the y's and you could see that you have a 4y and a 2y. And can't you just multiply the 2y by 2 to get 4? Better yet, since we want them to be opposite signs, and right now they're both positive, we could multiply this bottom equation by -2, so that that's a -4, and it'll cancel with the positive 4. So that's what we're going to do. Let me erase some of this, getting ahead of myself. We're going to multiply the entire bottom equation this time by -2, and we'll distribute that, but the key here is that it's going to give me a -4y that will cancel with the positive 4y and eliminate the y's. Alright, so the first equation is not going to change, so I'm just going to rewrite it. 3x plus 4y equals 6. The bottom equation is getting multiplied by -2, so that's a -10x. A minus 4y, like we talked about, that's great. And then a positive 8, so it equals 8. That's -2 times -4 is 8. And again, since these are opposite signs here with our y's, positive 4y, minus 4y, we're adding the equations together. So 3x plus -10x is -7x. 4y minus 4y cancels. 6 plus 8 is 14. Divide by -7. And x is equal to -2. 14 divided by -7. And then just take that x and plug it in to any of the original equations. I'm going to plug it into this bottom one right here before I multiplied it. I'm going to plug that in for x, -2. So 5 times -2 plus 2y equals -4. That's -10 plus 2y equals -4. Yeah. Add 10 to both sides. 2y equals 6. Divide by 2, and y equals 3. So the ordered pair -2, 3 is the solution. That would be where the lines intersect if we were to graph them. Alright, let's do a couple more examples of this. So in example 3 here, we have 4x plus 3y equals 8, and 3x minus 5y equals -23. Well, with both of these equations, I cannot just multiply one of them to get the other number. So, like, I can't multiply 3 times anything to get 4, and I can't multiply 3 times anything to get 5. So this is going to be an example where we're going to have to multiply both equations. Now, what I look for is opposite signs. If there's any that are already opposite signs, I'm going to try to eliminate that variable, and that's going to be our y. Technically, you could eliminate either variable you want. You could choose to eliminate the x's and maybe get them both to be 12, and then subtract the equations if you want. But, like I said, since the signs on the y's are already the opposite, we have a plus and a minus, a positive and a negative, let's multiply to get rid of the y's. So what do I need to multiply by? Well, what's the smallest number that, you could multiply so that 3 and 5, you can multiply them both by something to get that number. A lot of times it is just what 3 times 5 is, and that's 15. So I'm going to get them both to be 15, and that's going to require that I multiply the top equation by 5, so that that's a 15y, and I multiply the bottom equation by 3, so that that's a 15y, a minus 15y. So both equations are going to change. I'm going to rewrite them off to the right. We're going to have a 20x as I distribute the 5 on the top, and then plus 15y, and it equals 40. And in the second equation, that's going to be a 9x minus 15y equals negative, I know it's negative, 69. Alright, so now that my y's have the same number, 15, and they're opposites, that means that I get to add the equations together. Yay. That's usually easier than subtracting, so that's why I'm glad that we can add. So 20x plus 9x is 29x. The y's will go away. They are eliminated because they're opposites. And 40 plus a negative 69 is a negative 29. Oh, this will turn out nice. And then divide by 29. And x equals negative 1. Now, technically, you can plug that into any of the top 4 equations, like the original 2 or the 2 new ones that we got. It's usually easier to use one of the original ones because the numbers are a little smaller. I'm going to actually plug it into the top equation, so draw my arrow all the way over here, just because there were plus signs and not as many negatives. I don't know. You could do it into the bottom one if you want. So x equals negative 1. So 4 times negative 1 plus 3y equals 8. 4 times negative 1 is negative 4 plus 3y equals 8. Add 4 to both sides. 3y equals 12. Divide by 3. And y equals 4. Hope I did that right. Yeah. So the ordered pair negative 1, comma 4. Remember, your x always goes first in the ordered pair and your y goes second. Okay, and example number 4 before we go to the back of the page. Again, in this one, I do not see any way that I can just multiply one of the equations to get our coefficients to be the same. So I'm going to have to multiply both equations. I see on the y's again, I have opposite signs. So that means I'm going to try to get these two numbers to be the same. I can get them both to be 12. So we are just going to multiply the top equation by 3. That'll make that a 12. And the bottom equation by 4. That'll make that a 12 or a minus 12, which is extra nice. And here we go. We're going to distribute that. So we have 9x plus 12y equals negative 75. On the bottom we'll have 8x minus 12y, and that equals 24. And again, since our y's have the same numbers and they're opposites, I am going to add the equations together. So that'll give me 17x, the y's go away, 12y minus 12y is 0y. And then negative 75 plus 24 will be negative 51. Divide by 17. Use your calculator if you want to. You should get x equals negative 3. I'm going to plug that in to any of the original equations. You could even use the ones that we rewrote, but bigger numbers there, so that makes it usually a little bit more difficult. I'm going to use, this time I'll use this bottom equation, just because I want to. So that's going to give me 2 times negative 3 minus 3y equals 6. That's negative 6 minus 3y equals 6. Add 6. Negative 3y equals 12. Divide. And y equals negative 4. So you have the ordered pair negative 3, comma, negative 4, which is where these two lines would intersect if we were graphing them, which we would still probably be working on it. And this way we're done. Okay, at this point you have learned the 3 new methods in this unit. You've learned substitution, you have learned elimination with adding and subtracting, and you've learned elimination using multiplication now. On the rest of the notes today, we are going to just talk about when is it best to use each method. So this is really kind of like a review of this unit. So as we finish up the unit and we are basically getting ready for another test here, you need to be able to know when is the best time to use each one of these methods. So substitution is best when you have one of the variables that's already by itself in either one or both of the equations. So if one of the equations says x equals something, or you have an equation that says y equals something, then it's a good idea to use substitution, because you can just take whatever that variable is equal to and plug it in to the other equation. With the first type of elimination, that was elimination just using adding or subtracting. We did that when one of the variables has the same coefficient in both equations, the same number in front of either both of the x's or both of the y's. And we add the equations together if those coefficients have opposite signs, because that'll eliminate that variable. But if the coefficients have the same signs, then we subtract the equations together. And then we have to be really careful with our signs there and be careful with that subtracting. And elimination using multiplication is what we just did on the first part of these notes for today. And that was when none of the coefficients are the same. So we had to multiply one or both equations to get those coefficients to be the same. So now we're just going to do one example really of each type of method. You need to be able to look at a system of equations and to tell me which method you are going to use to solve that system. Alright, so with problem number 5 here, would substitution work? No, because I don't have an equation that says x equals or y equals something. So that method is not going to work, not substitution. What about the first elimination? Do I have any coefficients that are already the same? That's another no. So let's see, 4x and x, not the same. 3 and 2, not the same. So that's not going to work either. We're going to use the newest method, elimination with multiplication. So I want you to write that down, that we're going to use elimination. Let's abbreviate. Elimination and put a multiplication symbol in parentheses. So you can tell me which method we are using. Now let's go ahead and solve it. Great practice. Which variable would you like to get rid of? I'm going to choose to get rid of the y because they have the opposite sign already. So I'm going to get these numbers to be the same, and then I'm just going to be able to add the equations together. So I can do that if I multiply the first equation by 2. That'll make that a 6. And the second equation by 3. That'll make that a 6. But because they're opposite signs, they will eliminate when we add them together. Excuse me. Okay, so when I multiply that, we get 8x minus 6y equals 24. And the bottom will give me 3x plus 6y equals, whatever 14 times 3 is, 42. And again, because the y's are now the same, but they're opposite signs, we are going to add the equations. So that will give me 11x. The y's will go away. They are eliminated. And 24 plus 42 is 66. Divide by 11, and x equals 6. Still have to figure out what y equals, so I'm going to take that and plug it into right there. And I get 6 plus 2y equals 14. Subtract the 6. 2y equals 8. Divide by 2. And y equals 4. So that will be the ordered pair 6, 4. So there's kind of two parts to the answer here. I want you to be able to tell me which method, so read the directions carefully if they want you to tell which method you used, and then as you solve it, what's your solution? Okay, problem number 6. Is one of the equations already solved for one of the variables? Well, yes, it is. This second equation tells me x equals 2y plus 8. That means I can substitute 2y plus 8 in place of x in the first equation. So I'm going to use substitution. And let's just get right to it. So we're going to substitute 2y plus 8 in for x in that first equation. So 2y plus 8, I could put that in parentheses, and then plus the 6y equals negative 8. Those parentheses technically don't really matter here because it's all plus. So we're just going to add the y's together. That gives me 8y, lots of 8s. And then plus the 8 that's still there, right there, equals negative 8. Take away this 8 because I'm trying to get y by itself. So 8y equals negative 16. Divide by 8, and y equals negative 2. I still have to figure out what x equals. Don't ever forget that. You have to know what both x and y are equal to. So I'm going to take that negative 2 and I'm going to put it into the second equation for y because it says x equals 2y plus 8. So x will equal 2 times negative 2 plus 8. So that means x equals negative 4 plus 8. So that means x equals positive 4 because negative 4 plus 8 is 4. So that gives me the ordered pair 4, negative 2. So the two parts to my answer officially are that I used substitution and the answer solution is 4, negative 2. If we graphed it, that's where those lines would cross. Alright, let me draw a line here. Number 7. Well, does it say x equals anything or y equals anything? No. Are there coefficients that are the same? Yes, there are. On the y's, they have the same number in front of them. They both have a 3. So that's really nice. And it's also really nice because those 3's have opposite signs. So we can use elimination by adding here because they have opposite signs. So elimination, and then in parentheses put a plus sign because we're going to add the equations together. And we'll put that over here. When we add the equations together, 2x plus x is 3x. The minus 3y plus 3y cancels. That's the whole reason we added. And 12 plus 12 is 24. So 3x equals 24. Divide by 3. X equals 8. Now we have to plug that in, if I can see my original equations here. If x equals 8, I'm going to plug it into the bottom equation and find out what y equals. So that's 8 plus 3y equals 12. Subtract the 8, and 3y equals 4, and divide by 3. And I get a fraction. That happens every now and then. Lines aren't always going to cross at nice, perfect whole number points. So if we were to graph this, it would definitely be difficult to tell exactly where they cross. So luckily, that's again why we have other methods of solving systems. So the ordered pair here is 8, comma, and then I'm just going to leave it as 4/3. So again, two really parts to our answer. We used elimination with adding, and we have a solution. That's where they cross. All right, you're going to get some practice, and then we'll have one more video with some word problems, all different types of ways to solve them, I think. So go do a practice quiz, I think. Check your checklist.